AOPS number theory 7.24. Two farmers agree that pigs are worth $300 and that goats are worth $210. When one farmer owes the other money, he pays the debt in goats or pigs or goats with change received in the form of goats or pigs as necessary. For example, a $390 debt could be paid with 2 pigs with 1 goat received in change. What is the amount of the smallest possible positive debt that can be resolved in this way? So the GCD of 300 and 210, which is how much pigs and goats are worth, is 30. So let there be x pigs and y goats. So 300x plus 210y, if that's the debt, it can be factored into 30 times 10x plus 7y. So we want 10x plus 7y to be as small as possible, but not 0. So since the debt is a multiple of 30, we start by finding where 10x plus 7y, which is the debt, and the debt is equal to 30. So 10x plus 7y is equal to 1. So when x is equal to 2 and y is equal to 3, this is satisfied. So when it's like that, then the value is 1. So if you find the value of the whole debt, you multiply this by 30, so it's $30. AOPS number theory 7.25. A set of tiles numbered 1 through 100 is modified repeatedly by the following operation. Remove all tiles numbered with a perfect square and renumber the remaining tiles starting with 1. How many times must this operation be performed to reduce the number of tiles in the set to 1? So if the number of perfect squares from 1 to m squared is m, so if you remove m tiles, it will become m squared minus m, the number of tiles remaining. So to find how many m squared minus m is, how many perfect squares there are, well, m minus 1 squared is less than m times m minus 1, because m is greater than m minus 1, and that's equal to m squared minus m, which is less than m squared. So there are m minus 1 perfect squares up to m squared minus m, because m minus 1 squared is less than m squared minus m. So if you remove m minus 1 tiles, it will become m squared minus m minus in brackets m minus 1, which is also equal to m minus 1 squared. And the pattern of the remaining tiles, so first it's m squared minus m, and then it's m minus 1 squared. So the remaining tiles are alternate between perfect squares and products of the consecutive integers between the perfect squares. So if you count from 10 squared to 1 squared, it's down 9 perfect squares. So 9 plus 9 is equal to 18, so there are 18 operations. AOPS number theory 7.27. Let A, M, and C be digits with 100A plus 10M plus C times A plus M plus C is equal to 2005. What is A? So 2005 is equal to 5 to the power of 1 times 401 to the power of 1, which means this thing is equal to 5 to the power of 1 times 401 to the power of 1, which means 100A plus 10M plus C is equal to 401, because it has to be equal. One of them is 401 and the other is 5. And since this one is the bigger one, this one must be 401. So if A plus M plus C is equal to 5, then this is the way you express a 3-digit integer. And A plus M plus C is the sum of the digits of that 3-digit integer. So that means the number, that 3-digit integer, is 401, so A is equal to 4.